Hello everyone. Just let me adjust a little bit, then I will start the class. Hello. Hi. Hello. Okay, so today we are going to discuss again first few chapters: gravitation, system of particles, properties of solid, properties of fluids. Right? So without any delay, let us start with the class. First question: a force F equals to 5I plus 2J minus 5K acts on a particle whose position vector is R vector equals to I cap minus 2J cap plus K cap. What is the torque about the origin? How do good evening pro hacker, I am here. If you are asking about gaming talk outside, okay, I will block you if you continue. Last time also I saw you are discussing something about some free fire, etc. If you want to discuss it after the class, you discuss during the class. Listen to the class only. Okay, so the force, how to calculate force, how to calculate torque. Just a second, I need to change the color. So the torque is given by R cross F. Okay, torque is given by R cross F. Now how to do the cross product? So always remember that cross product is nothing but a determinant. Okay, I cap, J cap, K cap. Okay, and what is first this is the first row. What is second row? Second row will be your R vector, that is I cap means there is 1 minus 2 plus 1. Okay, and what about the third row? Third row will be 5 2 minus 5. 5 2 minus 5. Now you have to simplify this determinant to calculate the torque. So how to do the determinant? I know you are master in it. Okay, obviously first cover this. Minus 2 into minus 5, that is 10. Then it will be 2 into 1 minus 2. Okay, now J cap. Tell me, how do you do J cap? Do you do it like cross it, then you go in the same way and put a negative sign, or if you cross it and go in the opposite way and put a positive sign? Both are fine for the middle row, middle column, right? So cross, first you have to cover this, then I generally go from here to here and then here to here, so that my sign remains positive. Okay, so 1 is to 5, 5 minus 5 into plus 1, that is minus 5. Okay, plus K cap, again K cap is easy, cover this and this, 1 into 2. Okay, 1 into 2 is 2, and minus 5 into minus 5, that is minus 10. Minus plus 10. Okay, so 5 into 2 is 10, minus sign, minus plus. Okay, so it will be 8 I cap plus 10 J cap. Okay, 5 minus 5 is 10, and plus 12 K cap. Okay, so this is the answer. If you see the answer, 8 I cap plus 10 J cap plus 12 K cap. So option B is correct for this question. Okay, let's see how many of you have answered. Okay, most of you have answered correctly. Congratulations. Yes, now let's move on to the next question. A body having a moment of inertia about its axis of rotation equal to 3 kg meter square is rotating with angular velocity of 3 radian per second. Kinetic energy of this rotating body is same that of a body of mass 27 kilogram moving with a velocity v. The value of v. So first of all, first object is rotating object, second object is linearly moving object. So what is the kinetic energy for a rotating object? Those who forgot, the kinetic energy for rotating object is half I omega square. Okay, and what is the kinetic energy of a linearly moving object? That is half m v square. Now in this question these two are equal. Okay, so kinetic energy of the rotating object is equal to kinetic energy of the linearly moving object, so obviously we can cancel the half. What is I for the object is given 3, okay, and the velocity is given in terms of angular velocity, radian per second. Check that if it is given in RPM, okay, or RPS, you have to convert it to radian per second. Okay, so radian per second, so 3 square, and that is equals to mass of the object is 27 kg, so 27 v square. Okay, so 27 v square equals to 3 into 9. So 3 9s are 27, 9 cancels, you have left with 1, so v equals to 1 meter per second. Okay, so v square square root of 1 is 1, so correct answer is again option B, right? So those who have answered option B are correct, right? Prajwal, what are you saying? 67%. Okay, now let's move on to the question number 3. Another interesting question: which point is likely the position of the center of mass of the system shown in the figure? Okay, what is the center of mass of this system? Sir, how to attend longer question like long, bigger calculation without the calculator? Please tell me, sir. Mahantesh, there are few ways to calculate longer calculation. First of all, step number 1, when you are calculating, do not calculate each and every step. Okay, for example, if you are calculating, say x equals to a b c, a into b into c, and y equals to say x into y into z. Okay, now eventually what you have to do, either you have to multiply these two quantities or divide these two quantities. So do not do this multiplication individually, just write down the values, try to find the ratios first, and then put the values and calculate them. Okay, in many cases the values will be, some of the values will be cancelled, and in case if it is not done, for example, there are few questions in KCET historically, one question per year which comes a very long calculative question. Those questions I will say that leave that question till the end and answer them at the end. Now how do I identify those kind of questions? You will realize the question statements will be bigger, okay, the lot of informations will be given, and you realize that more than one concept is required to answer those questions. Those questions you attempt later on. Okay, some of them will be easier, values will be cancelled and you will get a simple value. Some of them values may not be cancelled, you need to solve longer. For example, there was a question I think in 2023 or 2024 in electrostatics. That question, if you try to attempt, you actually fail, you will fail in the KCET, or maybe your rank, if you try to answer those questions, even if you have answered that question correctly, you will not score well in KCET, because that question requires 10 minutes to minimum to solve it. Okay, all the calculations, there is no shortcut in that question, and the page will be insufficient to solve that question. So those questions you have to skip. Okay, there are few questions. As I am telling you, every year generally one question which is very lengthy, that question you should not attempt. Remaining question you should attempt, and that question you can attempt as a guess, but otherwise you should not try to solve those questions. Okay, that is one. Now answer this question. What is the answer to this question? Only few questions answered this correctly. Okay, now so here if you see that this portion of the object is air, this portion of the object is air. I will try to solve the questions little faster today. Okay, so this portion is air, this portion is sand, right? So most of the mass of this object is located actually here. Most mass of the object is located actually here. So where do you expect to get the center of mass? Are you expected to get the center of mass at somewhere there is no mass at all, or where the most mass is located? Okay, so basically it will be at the point where most mass is located, right? So it has to be D. Now here if you see the options, A, B, C, D is not given in order, it is given in a different order. So correct answer for this question is option B, where most mass is located, which is D. Okay, C is not the answer. If both of them, if it is a simple block, imagine it's a simple block. Okay, imagine it's a simple solid block, then where you are expecting the center of mass. Center of mass will be at the intersection of the diagonal, that is this point. But here half of this is air and secondly it is sand. So it will be, sand is heavier obviously than air. Okay, air has very small mass. So the center of mass will be where most of the mass is located, which is inside the sand. So correct answer will be option D. Not option D, sorry, option B, but point D. Okay, now, so I think most of you have seen the point D and marked options D without reading the question. That's why reading the question is also important. Now let's move on to the next question. A particle moving uniformly along a straight line as shown in the figure. During the motion of the particle from A to B, the angular momentum of the particle about O remain constant, increases, first increases, then decreases. Now remember that generally except one special case, that question I think I will discuss in our Sunday's live. That chapter is there in Sunday's live, not today. Except of very few special cases, increases and decreases actually wrong option. Okay, first increase then decrease, that is a wrong option. Okay, so it can be constant, it can be increases, it can be decreases. This is just given as a very common poor option. Okay, so let's see who has answered this. Let's see. So how to calculate, hello above ABP, AB Patila. Comet K crash course is like Comet K launch pad, no clone. Comet K launch pad is basically where we discuss only the important questions. In Comet K crash course we discuss all type of questions including PYQs and common type of questions as well. Okay, so it is actually, you can say that launch pad is a subset of crash course. Okay, where we are discussing in launchpad we are only discussing important questions, whereas in crash course we will be discussing all the different questions. Also we will have live doubt classes, you will have tests according to Comet K syllabus, so everything will be there. Whereas launchpad is only where we are solving questions. Launchpad we will also start this year as well, so don't worry. So let's see, some of you have answered, initially the options was wrong, now most of you have corrected it. Now let us understand what is angular momentum. Angular momentum is given by r vector into linear momentum. Okay, linear momentum is mass into velocity, so you can say that it is mass into r cross v. This is the angular momentum. Now velocity is constant, it's mentioned it is moving in a straight line, that means velocity is constant, v is constant, mass is obviously constant. So we have to check what about r vector. What is r vector? Is it the position vector? No. If it is position vector, then it would have been increasing, because position vector starting from negative it goes to the positive value, so position vector value is increasing, then r would have been increasing. But here r is not the position vector, r is actually the perpendicular vector from the origin towards the point, because origin is fixed, this is the path through which it is traveling, so this is the r vector, this is the r vector. Okay, because r vector is fixed, that means we will be having that r is fixed, v is fixed, m is obviously fixed, that means the angular momentum will also be fixed, so angular momentum will remain constant. Option A, those who have answered option A are correct, those who have answered option B are not correct. Okay, it is not increasing, it is remaining constant, because r vector, this is a very conceptual question, r vector is the perpendicular, draw the perpendicular from the point where you are measuring it to the path of the object, and then you do the r cross b. Okay, if it is a curved line, then you have to take tangent and each and every point, and then you have to calculate, which is a very critical, angular momentum will change because it's a moving a straight uniform path. So velocity is constant, remember that one very important thing, if velocity is constant, angular momentum will also be constant, that is a common thing. the angular speed of a motor wheel is increased from 1200 rpm to 3120 rpm in 16 seconds. The angular acceleration of the motor wheel is. So what is the angular acceleration of the motor wheel? So first of all, what is the, so here if you see that the initial angular speed is 1200 rpm, final is 3120 rpm. So rpm, whenever rpm is given, you have to convert it into radian per second. Rpm is not an unit. So what is rpm means? Rpm means revolution per minute. Revolution means one rotation is called one revolution. One rotation is one revolution. And what is the angle that it covers in one revolution? Suppose the object starts from here, okay, and it covers 90 degrees, 180 degrees, 270, 360. That is total angle covered is 2 pi. Okay, so total angle covered in one revolution is 2 pi. So your starting point and ending point are same. So 1200 rpm is actually equals to 1200 divided by 2 pi, each revolution angle is 1200, 2 pi, so it will be 1200 into 2 pi divided by 60, because it is revolution per minute. If it is given revolution per second, then you can directly just multiply by 2 pi and it will be converted into radian per second. Okay, but here it is given in minute. So this is the angular velocity 1, initial or initial angular velocity omega I. So cancel the values, you will get 20, so it will be 40 pi. 40 pi is the initial angular speed. What is the final angular speed? Final angular speed we can easily calculate, 3120. Now we know the rule, 2 pi divided by 60. So 0, 0 cancels. It will be 52. Okay, 5 6 are 30 and 2 6 are 12. So it will be 52. 52 into 2 pi is 104 pi radian per second. Now sir, what? Now what we have to do? So omega I and omega f is calculated. Now we will use the same thing that we have used in our linear motion, that is acceleration. What is the acceleration in linear motion? Acceleration was final velocity minus initial velocity divided by time, right? That was the formula for acceleration. Similarly, angular acceleration is same formula, only in terms of rotational velocity, okay, divided by time, and unit will be radian per second square. Okay, so what is the final velocity? Final velocity is 104 pi. What is initial? Initial is 40 pi. How much time it took? It took 16 seconds to do that, so divided by 16. Okay, so it will be 64 pi by 16. So 16 4s are 64, so it will be 4 pi radian per second. Okay, so correct answer is 4 pi radian per second. Option D is correct answer for this question. Okay, some of you have answered correctly, some of you have answered it incorrectly. Hi Prajwal. What is anti-clockwise? Clockwise or anti-clockwise is not matter over here, at least for this problem. Now before I continue, just I just wanted to remind you that our KC30 batch is live. It is already started, and if you still want to register for it, the link of the KC30 is given in the description section of this video. You can go and check that out. Okay, the price is still 2499. And already the classes started since Monday. So if you still want to join it, don't be late, because you will miss out on the live classes, you will miss out on the preparation time. So if you really want to join today. KC30 batch is already live. Now let's move on to the next question. The moment of inertia of a rigid body about an axis does not depend on its mass, does not depend on its shape, depends on the position of the axis of the rotation, does not depend on its size. So what is the meaning of that? Suppose we have a axis of rotation if this is a mass m, what is the moment of inertia of this object? The moment of inertia of an object is given by half m r square for a point mass located at a distance r from the axis is given by half m r square. So it depends on the position of the axis. Obviously it depends on the size. Bigger, if this is for a point mass, if the object is bigger, then you have to use the method of superposition. For example, if you consider an object, okay, the object is very big, axis is like this. For this object, the depending upon the which axis you are considering, the moment of inertia will be different. Okay, so it depends on its shape, it depends on its size, it depends on its mass, okay, and also it depends on the position. Now if you see all these options, first these options it says does not depend. So does not depend is incorrect because it depends on all of them. In fact, it also depends on the position of the axis. So that's why we will say option C is correct for this question. Okay, 50% students answered this one at least correctly. Okay, but some of you still have answered wrong, option A, meaning some of you have answered option A. I don't know why you answered option A. It depends on mass, right? Now let's move on to the next question. 2024, a ceiling fan is rotating around a fixed axle as shown. The direction of the angular velocity is along. So if you see in the diagram, the x, y, z axes are also given and the rotation is given. This is from the top of the ceiling fan. This is from the bottom view of the ceiling fan. Okay, if you observe from the top, you will see that the fan is rotating. If you see from the top, the fan from the bottom, the fan is rotating like this. Now what will be the angular velocity? What is the direction of angular velocity? How to calculate the direction? So very easy, right hand rule. So take your hand, rotate the fingers in the direction of rotation. Whatever is your thumb, that will point the direction of rotation, okay, or direction of angular velocity. So if you see that here the angular velocity is downward, okay, so if you consider this one, basically you have to this is the bottom view. So from top, if you do that, it will actually coming down. Coming down means what is the direction? Negative z axis. So negative z axis means unit vector is minus k cap. Okay, so the in this case the answer will be minus k cap. Okay, so this is a very common question, common style of question. Okay, most of you have answered B. I don't know why. Okay, and there is no relationship with J cap. The fan is rotating like this. Okay, fan is rotating like this. So always take your fingers, align them in the direction of rotation. Suppose it is rotating in the opposite direction. Okay, if it is rotating in the opposite direction, then you have to curl your fingers like this. It will be along the z axis. Okay, so it will be along this axis only. Remember that whenever an object is rotating, the angular vector will be always along the axis of rotation. Okay, it will be either upward or downward based on which direction it is rotating. It will not be in a sideways direction. So this is the z axis, this is the z axis, right? So check the diagram properly. It is very clearly visible to all of you, right? So this is the direction of rotation. So if it is the direction of rotation, then you will get this as the direction. So correct answer is option D. Okay, now let's move on to the next question. A body, this is a long question. A body of mass 1 kg. So I will start solving it. You also start solving along with me. A body of mass 1 kg suspended by a weightless string passes over a frictionless pulley of mass 2 kg as shown in the diagram. So here we have a 2 kg pulley, here we have a 1 kg mass. Okay, the mass is released from a height of 1.6 meter from the ground. With what velocity does it strike the ground? So the mass is released, now it is about to strike the ground. What will be the velocity of this mass? Now if you see that in this situation, what is happening? Potential energy is converted into kinetic energy. Now whose potential energy? So this object is located at some height. This object is located at some height. That means the potential energy of this object is converted into kinetic energy of this object as well as kinetic energy of this wheel. Because when this mass falls, the wheel will also rotate. Okay, eventually whatever is the velocity of this object, the wheel will also take the same linear velocity. Angular velocity will be different, but linear velocity will be same as that of the object. Okay, now in this question the this height is given 1.6 meter and the okay, now I think the radius of the pulley should also be given somewhere. Suspend mass 2 kg as shown in the figure. The mass is released from a height of 1.6 meter from the ground. What is the velocity does it strike with the ground? Let's see anyway. I think radius will cancel anyway. Let's see. Okay, so suppose the radius of this wheel is capital R. Radius of this wheel is capital R. Now I will show you how can you solve this problem without using a calculator, because this is a long question. So how to calculate that? First of all, what is the initial energy of the system? Initial energy of the system is potential energy. Potential energy is given by mgh. What is m? M is 1 kg. Okay, g is 10 and height is 1.6, so this will be 16. Okay, so initial energy is 16. Leave it. Now let's move on to the final energy. What is the final energy? Final energy is kinetic energy. Final energy is kinetic energy, completely kinetic energy, which is half mv square plus half I omega square. Very interesting. Okay, it will be half I omega square. Okay, so because it's a circular ring, its kinetic energy will be half I omega square. Now we know that half m is 1 kg into v square. Okay, and that is equals to half, that is plus half into what is I for a circle, circular ring. I for a circular ring when it is rotating around an axis passing through its center is half mass of the ring into r square. Okay, but radius is not given obviously. So how to cancel that? Because omega is given. What is omega? Omega is linear velocity by radius. Remember that. So linear velocity should be same as the velocity of the object. Velocity of the object and linear velocity of this pulley will be same. So here it will be v square upon r square. Okay, square is there, omega square. So v square by r square. So r square cancels, and you get half v square plus 1 by 4 and mass of the string is pulley is 2 kg. So 2 into v square. Okay, so again half cancel. So half plus half v square. That is simply v square. Now this is final kinetic energy, this is initial potential energy. Both has to be equal. So Ek must be equals to initial energy. So v square must be equals to 16. So v must be 4 meter per second. Very interesting, important question. Okay, and as I mentioned, don't do the calculation step by all at once. Do this step by step method is very important. So if you solve it using variables, r square will cancel. That is how you should solve it. Okay, so correct answer is 4 meter per second. Option D is correct. Okay, now again many of you have answered the wrong. Some of you have ignored the wheel completely, used 4√2, which is wrong. Why it is not a ring? Which MOI we should take? I don't understand what is your question. Sir, why it is not a ring? Which one is not a ring? This is a circular disc. Okay, this is a wheel, pulley. So it's a disc, it's not a ring. Okay, so unless and until this mentioned a ring, what is a ring by the way? Ring has only outer thing, there is nothing inside. Have you ever seen something on which a pulley is only a ring? Pulley has a mass, pulley has a disc. Pulley is like a disc. Okay, even though pulley has the shape of the pulley is slightly different than what is shown over here. This is an ideal pulley. Pulley is like a disc, it is not a ring. Okay, so you cannot use the formula for a ring, you have to use the formula for a disc. Okay, clear? Pulley, remember that pulley is, you have done experiment using pulleys. Okay, in your sonometer experiment there are the point through which you have hang your masses, that is a pulley. Okay, you have done experiments using pulley. So that, remember that. You also, I think, done a gravitational experiment in your PU1 using a pulley. Okay, so pulley is a solid object. Now this question came in 2025. In my personal opinion, this should be a bonus question, even though they have not given it as a bonus. Anyway, we will solve it. 3 particles of mass 1 kg, 2 kg and 3 kgs are placed at the vertices A, B, C respectively of an equilateral triangle ABC of side 1 meter. The center of mass of the system from the vertex A is. So now first of all they assume that it is an only xy coordinate, it is not any other coordinate, and the problem can only be solved in a particular configuration. The configuration is, if you keep the pulley like this, okay, and this okay. I forget that, let me draw it only. So this is x-axis, this is y-axis. Okay, only x and y they are assuming is there. It can be z-axis also, first of all. So point A is given at origin. Point A is at origin, that means it is at 0, 0. What about point B and point C? So either this question has to be accompanied by a diagram, or this should have been given as a bonus question. Because this problem can only be solved if you take the point B over here and C over here. Okay, this is the only way you can solve it. If you take the point B over here or C over here, you will get a different point. If you take the point B over here, C over here, you will get a different answer. Okay, so it depends only on the how you take the masses. 3 masses are also not same, so you cannot interchange the points. Okay, so the point A has 1 kg, point B has 2 kg, and point C has 3 kgs. Now you need to know the coordinates of this problem. For that, it is given that the side of the triangle is 1 meter. So this distance is 1 meter. So this is 0, 0. So what will be this point? This point will be 1, 0, because obviously it is along the x-axis. Okay, so it will be 1, 0. What about the point C? Point C will have a point of half and √3/2. How to calculate this? First of all, if you draw a perpendicular from this will bisect this side. That means the x coordinate is half. Okay, and what about the y coordinate? For that you have to apply Pythagoras theorem and calculate this distance. Okay, this distance is half. Okay, you need to calculate this height to calculate the y coordinate. To calculate that, this side is 1, this is half. So what about this? 1 square minus half square root, that will come out to be √3/2. Okay, so remember that. So this is a triangle, equilateral triangle. So you have to remember, you have to know how to find the 3 vertex. One vertex is given 0, 0. Another vertex you can calculate 1, 0. What about the third vertex? Third vertex will be half and √3/2. Now we will use the formula for center of mass. XCM is given by m1 x1 plus m2 x2 plus m3 x3 by m1 plus m2, m1 plus m2 plus m3. Okay, so what is m1? m1 is 1 kg. What is x1? X coordinate of 1 is 0, plus what is m2? m2 is 2 kg. What is x coordinate? X coordinate is 1. What about third point C? Third point has a mass 3 kg, x coordinate 3/2. So it will be 3 into 3/2. Sorry, not 3/2. X coordinate is half. X coordinate is half. Okay, divided by 1 plus 2 plus 3. Now you have to add all the masses. Okay, this is how you should calculate center of mass. So 2 plus 3 by 2 by 6. So that is 4 plus 7, 7 by 2, 7 by 12. Okay, so XCM is calculated, which is 7 by 12. So only one of them will be correct, either A or C. Now we have to calculate the YCM. What is YCM? YCM will be given by obviously the same formula, M1 Y1 plus M2 Y2 plus M3 Y3 divided by 6. So M1 plus M2 plus M3 is 6, so same value will remain same, 1 into 0. Okay, Y coordinate is 0 for the mass 1, Y coordinate is 0 for mass 2 as well, so it will be 2 into 0, right? Y coordinate is 0 for both of them. Y coordinate is root 3 by 2 for the third mass, so it will be 3 root 3 by 2 divided by 6. Divided by 6. So it will be 3 root 3 by 12. Okay, so correct answer is option A. Okay, even though option A we are getting, as I mentioned, this should be a bonus question. Good evening, Manju. Right, now let's move on to the next question. What happened, Prajwal? Why you are giving me some sign? I did not understand what you are meaning. I can only understand that buffer, and then you are showing some sign. Next question, question number 10. A satellite in a circular orbit of radius capital R has a period of 4 hours. Another satellite with the orbital radius 3r around the same planet will have a period of. Now we know that so radius is obviously when you are calculating the radius from the center of the earth, right? So for satellite or for planet, the same law is applicable, which is the law of Kepler. Kepler says that square of the time period is actually proportional to cube of the semi-major axis. Here it's a circular orbit, so it's just the radius of the circle. Okay, first one has a radius r. Okay, first one has a radius r. Second one has a radius 3r. Okay, so it is the ratio of these two quantities. So T1 square by sorry, I just make a mistake. Okay, the square of the time period is proportional to cube of the semi-major axis. So T1 square by T2 square equals to r cube by 27 r cube. R cube cancels, it will be 1 by 27. Okay, so T2 square is actually equals to 27 into T1 square. Okay, what is T1? T1 is 4. So it will be 27 into 4 square. Okay, so T2 will be equals to square root of 27 into 4 square, that is 4 into 3 root 3, that is 12 root 3 hour. Okay, correct answer is 12 root 3 hour. I think okay. So 12 root 3 is not given. Very clever. What they have given is they have given 4 root 27. 27 is 9 into 3, that is 3 root 3. So if you see the option, they have given 4 into square root of 27. So don't confuse if you solve it and then you see that the answer is not coming. Just check once if any stages you are getting this value or not. So 4 root 27 is the time period of the new satellite. Okay, so option C is correct. Someone was saying option A, so those who are answering option A are incorrect. Okay, hello Deepthi. Screen is looking blurred. Just give me a second, let me check it once. It is perfectly fine. No changes are there. Right, now let's move on to the next question. A planet revolves around the sun in an elliptical orbit. The linear speed of the planet will be maximum at. The linear speed of the planet will be maximum at A, B, C or D. Okay, there are 4 points at which point the linear speed will be maximum. Okay, check the option first. Okay, check the options first. You have to answer the option, not the point. Okay, Kepler's law, yes, Deepti. So remember that speed of the planet is actually more when it is closer to the planet, because it has to cover a longer distance to maintain its aerial velocity law or area law, right? So basically it means that Kepler's law says that it covers equal area in equal time. So if you want to cover a large area in this, you can do that by covering a very small distance in this, because this area is much larger. So if you want to compensate that, you have to travel very fast in this region. Okay, this is called perihelion, and the farthest point is called aphelion. Perihelion is the point when the planet is closest to the sun. So remember that this is not peri. Okay, peri pizza, it's perihelion. This is aphelion. Okay, so remember that when the object is near its perihelion, the speed is maximum. The speed is maximum here and speed is minimum here. Okay, anywhere in between, speed is between these two values. Okay, so correct answer is point A but option C. Point A but option C. Yes. Sir, I shall complete second PUC all chapters, then come to PU1, or please suggest, sir. So Deepti, what I will suggest you that right now, because you have given your PU2 exam right now, right? So you have some level of preparation for your PU2, but PU1 you have forgotten. So that's why you just revise PU1 now, and you can cover the PU2 chapters in a while. Anyway, we will be covering, if you go with our pace, that is very good, because we will be covering our PU1 chapters by Sunday. So Sunday is the last live for PU1. From next live Tuesday onwards, the lives where we will be discussing your PU2 chapters. Okay, so PU2 chapters, I suggest you, if you want to revise anything, revise your PU1s, because those are completely blank from your mind. Okay, then within 1 week complete all the PU1. Do not take more than 1 week. Within 1 week complete entire PU1. Then you, whatever time is left, 20 days, you should focus on your PU2, because obviously PU2 is more important. And at the end stages of the preparation, you should practice with more and more tests. Every day you should take one test. Okay, so that your confidence is boosting. Every day take one test in the morning for chemistry, afternoon for physics, then mathematics in the evening. So 3 tests every day. Then your brain will be ready for your KCET. You will be in the zone of KCET. Okay, that's how you should prepare. Now next, 2 satellites of mass m and 9m are orbiting a planet in orbits of radius capital R. The periods of revolution will be in the ratio of. So here we have a planet, tiny planet, not our Earth, some planet, some alien planet. 2 satellites are orbiting the planet. Okay, one has a mass m, one has a mass 9m. Okay, what will be the ratio of their time period? Suppose this one has a time period t1, this one has a time period t2. What will be the value of t1 by t2? Quickly, this one I will answer very quickly. Which chapter is more weightage of first PU class? So in the first PU class, for example, motion in a plane, laws of motion, okay, then system of particles, gravitation. These chapters are important because from these chapters you are getting 2 questions, okay. Other chapters you are getting 1 questions each, but motion in a straight line is important because the formulas, equations, calculations that you use in that chapter, that carry forwarded to your PU1 chapters and PU2 chapters as well. Okay, that's why you should not skip your motion in a straight line chapter as well. Units and dimension helps you to answer dimension based question in your second PUC chapters. That's why units and dimension also should be studied. Remaining chapters, for example, thermodynamics, even though the chapter looks scary, the KCET problems are easy from that chapter. Okay, thermodynamics. Then we in comparatively viscosity, fluids, properties of fluids, properties of solids can be little tricky if you have not studied them in the past, okay, but other chapters are relatively easier. So that is why I recommend that you should start with these first few chapters, and then move on to your chapters of thermodynamics, thermal physics, kinetic theory, waves, and oscillations. Those chapters relatively easy to answer. Okay, so what is the answer for this question? Now remember that time period of a planet is independent of the mass. It only depends on the distance. Time period depends only on the distance. Kepler law states that it depends only on distance. It does not depend on the mass. So answer is 1:1. This is a fool question. Okay, so this is a foolish question that is trying to make you fool, thinking that what mass, more mass means less time period. Actually no, time period is independent. T square is proportional to R cube. Okay, there is no mass involved over here. Now next, variation of acceleration due to gravity with distance x from the center of the earth is best represented by. So here is earth. Okay, you are trying to calculate the center of gravity starting from center. This is center of the earth, and as you are moving, how the gravity changes. So obviously we know that gravity is maximum on the surface. Okay, maximum on the surface, and as you go down or go up, gravitational acceleration decreases. Now how it changes? Obviously from this graph it is very clear that here is showing that gravitational acceleration is more inside and more outside, but it is minimum on the surface, which is wrong. If you see this graph, it is keep on increasing, which is also wrong, because gravitational acceleration is maximum on the surface. Here it shows that it is maximum on the surface, but there is nothing inside the surface. Okay, so gravitational acceleration inside the earth is not 0. We do the calculation. Okay, in fact inside the surface of the earth, if you calculate, gravitational acceleration is proportional to radius. Okay, whatever radius you take from the center, okay, inside the surface it is proportional to radius, outside the surface it is inversely proportional to radius. That means the correct graph is this one. It is increasing linearly inside the surface, and it is decreasing with a 1/r pattern in here. So correct answer is option D. Option D is correct answer. Okay, most of you have answered at least this question correctly. Now let's move on to the question 14. Before moving on, I just wanted to remind you, those who are preparing for Comet K, our Comet K crash course is also available, and the classes will start from 6th of April. You can go into the link of the description section and enroll for Comet K 30. The course starts with the 2499 price tag, and it is very affordable, and it's one of the best Comet K crash course available. Okay, here you will get complete class 11-12 coverage, that is your PU1 PU2 coverage. You will get 5 full-length Comet K mock tests, daily live doubt classes. You will get the notes, you will get the daily practice papers, etc. And now remember that if you want to purchase the test series as well, test series is also available separately. Last year we only did crash course. Some students wanted the test series, so we have launched the test series for only 999 this year. You can purchase the test series separately for Comet K as well. Okay, not only ABHYAS, but you can purchase the test series for Comet K. Now question number 14. A space station is at a height equal to the radius of the Earth. If nu is the escape, or v is the escape velocity on the surface of the Earth, the same on the space station is. So, for example, suppose you are orbiting around the International Space Station, which is rotating around some height, say at a height of r from the surface. Okay, then so this is our planet Earth, this is our space station. Okay, the height is r, so total height from the center will be r plus r. Okay, that this is r. Now the escape velocity on the surface of the Earth is v. What is the escape velocity here? That is our question. How to solve that? So we know that escape velocity on the surface of the Earth is given by square root of 2g r, right? This is the escape velocity on the surface of the Earth. Now what is g? G is gm upon r square. M is mass of the Earth. So let's put that. So it will be gm by r square into r. Okay, there is a 2 also. So r cancels and you get square root of 2gm upon r. This is also a formula for escape speed. But if you don't remember this formula, then you have to go from here. Okay, this is the escape velocity on the surface of the Earth. So what will be the escape velocity at a height capital R from the surface? What will be the escape velocity? So everything will remain same. Obviously gravitational constant is universal, mass of Earth will remain constant. If you see that this r is the radius, because when you are considering an object on the surface, this is the distance from the center. This represents center distance from the center. Now what is the new distance from the center? New distance from the center is r plus r, that is 2r, right? So the same formula will be same. Okay, 2gm upon, only thing will change is this r will become 2r. So you can write this as 1 by root 2 into VE. Obviously if you take these 2 out of the square root, everything becomes the escape velocity. So as you go up, the escape velocity will become 1 by root 2 times the escape velocity on the surface. Okay, so correct answer is option C. Most of you have answered C, some of you have answered wrong B as well, but anyway, so option C is correct. Now let's move on to the next question. Okay, if you have any doubt, you can ask her. T square equals to 4 pi square a cube gm. This is the formula sir used for question number 10. Question number 10. What was the question number 10? No, here you don't need to use that formula. You just simply consider that t square is proportional to r cube, because it's a value of 2 cases. You just need to calculate the you need just to write that t square is proportional to r cube. That is sufficient. Okay, so you don't need to write the entire formula. Simple t square proportional to r cube is fine. Now answer question number 15. The value of acceleration due to gravity at a height of 10 km from the surface of the Earth is x. At what depth inside the Earth is the value of the acceleration due to gravity has the same value as x? Now if you see this question, the height is 10 km. 10 km is very small value compared to radius of the Earth, which is 6400 kilometers, right? So we will use a formula that g dash at a height close to surface of the Earth is given by 1 minus 2h by r. Okay, this is a formula. Normally what is the formula for gravitational acceleration at a height? These all you have done as a derivation in your PU1. Normally the formula is 1 plus h by r whole square. This is the formula. If the height is high, you have to use this formula, but if the height is smaller, this formula can be approximated at this value. Okay, you can approximate this to be at this value. Now that is how you improve. Okay, I will give you the formula sheet in another few days. Okay, once formula sheet is there, this all formulas will be mentioned. So you have to understand those formulas. Either you memorize or you understand, whatever way you are comfortable. Okay, so but if you want to save time in the exam, memorization is the one of the good way. So gravitational acceleration at a height is given by this. Okay, gravitational acceleration at a depth is given by g into 1 minus d upon r. Okay, this is the gravitational acceleration at a depth. Now it says that where the values will be same. Values will be same means gravitational acceleration at a height will be same as gravitational acceleration at a depth. Okay, that is g into 1 minus 2h upon r equals to g into 1 minus d upon r. Okay, so g cancels and 1 minus cancel, you get 2h upon r equals to d upon r, r cancels, you get the depth is equals to 2h, that is 2 into 10 kilometers, that is 20. For small heights, now you can remember it this way also, for small heights the depth is twice of the height. Okay, so depth, if they are equal for depth and height, then for small heights it will be just double, so it will be 20 kilometers. But this logic and this formula is not applicable for heights higher than 100 kilometers. Okay, for 100 kilometers and above you have to use the general formula. Two bodies of masses 8 kgs are placed at the vertices A, B of an equilateral triangle ABC. A third body of mass 2 kg is placed at the centroid G of the triangle. If AG equals to BG equals to CG equals to 1 meter, where should the fourth body of mass 4 kg be placed so that the resultant force on the 2 kg body is 0? So let us understand this problem. Equilateral triangle, this is point A, this is point B, this is point C. The center of gravity or the center of the triangle, this is equilateral, so center of mass, center of gravity will be same. So this is the point G. This distance is given 1 meter, this is also given 1 meter, this is also given 1 meter. Okay, now what? Now you have to find, so here we have what is the mass, by the way, I forgot, 8 kg. So both are 8 kgs. Now this point, the mass that we have in our hand is 4 kg. That is 4 kg. If it was 8 kg, we could keep an 8 kg over here and we can say that the net force at this point would be 0. Symmetrical, but here we have only 4 kg. Then what? So how to calculate that? Suppose, because it's a 4 kg, obviously it will be not be at the point C, so it has to be some point P. Suppose that distance is R. This is a tricky problem. Okay, even though the problem looks easy, it's a tricky problem. So this distance, say R. Okay, now what? Now we have to calculate the force on this mass. Okay, both forces will be equal. Calculation wise little lighter. Okay, both forces will be equal. You can calculate any one force, that is fine. So what is the force here? Sorry, I made a mess. So here the force is in this direction, here the force is in this direction. Okay, their resultant will be along this direction. So you need to put a mass over here, so that the resultant force, they cancel each other. Okay, now what is this 8 kg force? Force 1 or force A, say, that is given by G m1 m2 by r square. Okay, so if you see that in the problem it is mentioned that a body of mass 2 kilograms is placed at the center. So here the mass is 2 kilograms, right? So G into 8 into 2 divided by 1 square, or it will be 16g. Don't put the value of g, eventually it will cancel. Okay, so the force A is 16g. Force B will be the same value, the direction will be different, but it will also have a value of 16g. What about the force due to this? Force due to this will be F, say P. Here it is a point P, it is kept on a point P. So Fp will be given by G, mass is 4, okay, the center mass is 2 and distance is r. Okay, so it will be 8g by r square. Now remember that these two values are different. Okay, these values are different because they are acting at some angle. They are acting at some angle. So you cannot simply add these two and compare it with this. Okay, so you have to use something else. What thing that we will be using? We will be using something called Lami's theorem. Those who know, it is Lami's theorem. What is Lami's theorem says? Suppose we have three forces, F1, F2, F3, and if they establish an equilibrium, okay, and let me change it a little bit so that it can avoid confusion. Suppose this is F3. Okay, if they establish equilibrium, suppose this angle is alpha, this angle is beta, this angle is gamma. Then Lami's theorem says that force divided by opposite angle means the angle which is opposite to this vector, that is sine of alpha, is equals to next force divided by sine of the again opposite angle, and that is equals to F3 divided by sine again opposite angle. Okay, they will be same. If these three forces gives you equilibrium, then the ratio of the force and the opposite angles sine will be constant. That is Lami's theorem. So here if you see that this is an equilateral triangle, this is center of gravity. So all these angles are 120 degrees. All these angles are 120 degrees. All angles, all three angles. Okay, so if you take the any one of the force, suppose we are taking FA divided by sine 120 equals to, now we take the unknown force which is Fp, again the opposite angle is same 120, so sine 120. Okay, this is magnitude wise. You don't need to calculate their direction etc. This is magnitude wise. So sine 120 cancels. Fa is 16g and Fp is 8g by r square. Okay, so r square is actually equals to g cancels, 8 by 16, that is 1 by 2. So r is equals to 1 by root 2. Okay, so r is equals to 1 by root 2. So now let us look into the option. At a point P on the line on CG such that PG equals to 1 upon root 2. Okay, on a line CG, okay, this is point G, right? This is our point G. So on the line CG such that the PG distance, P to G distance is 1 upon root 2. Okay, so correct answer for this question is option B. Okay, so option B is correct answer. This is a tricky question. As I mentioned, this is a tricky question. Not all questions are easy. When a planet revolves around the sun, in general for the planet, linear momentum and linear velocity are constant. Linear momentum and aerial velocity are constant. Kinetic and potential energy of the planet are constant. Angular momentum about the sun and aerial velocity of the planet are constant. Let's see who can answer this one. Where do you get notes which you were explained here? Mohammadi Tharathari. Okay, you will get the notes on our WhatsApp channel. Okay, join our WhatsApp channel. The link, drive link, we generally after the class is over, I will save this file and I will upload this file into a drive link. It will be shared with you. Do not request access. You download it on your computer, on your mobile phone and use it. Okay, some students, I don't know why they request access. You don't require any access. You have the access to download the folders, download the lectures, download it, and then you can get the lecture on your own. Okay, so you have to join the WhatsApp channel. The WhatsApp channel link is given in the description section of this video. You can close the live chat and then you can click on the read more. There you will get the WhatsApp channel link. Okay, join there. When a planet revolves around the sun in general, which was correct, linear momentum and linear velocity are constant, linear momentum and areal velocity are constant, kinetic and potential energy of the planets are constant, angular momentum about the sun and areal velocity of the planets are constant. Now according to Kepler's law, areal velocity is constant, and from the rotational motion, angular momentum is constant. Linear momentum is not constant. Okay, linear momentum would have been constant if there is no force acting on the system. Here gravitational force is acting on the system, so linear momentum is not constant. Only angular momentum and areal velocity of the planet is constant. So option D is correct. Okay, still some of you are answering wrong. Now let's move on to question number 18. The following 4 wires of length L and radius small r are made of same material. Which of these will have largest extension when same tension is applied? So here we have a wire. Okay, the length is L, radius is r. Okay, material is same. There are different wires are there. Okay, you apply some force and it says that which will have the largest extension. That means the change in its length when you apply force. Suppose the original length was this, it expanded by a length distance delta L. Who will have the largest extension? So how to do that? So we know that Young's modulus of a material, again now we are moving on to our next chapter. Young's modulus for a material is given by force divided by area divided by change in its length divided by length. This is called stress, this is called stress, and this is called strain, if you remember, right? Stress by strain, that is Young's modulus. Now force is same, Young's modulus is same, only thing that is changing is area and length, and correspondingly you have to calculate delta L. Now let's simplify this. So y equals to F into L divided by delta L into A. Okay, or now delta L will be, from here we are calculating delta L will be FL by Y into A. Now F and Y is constant, so obviously what we need to check? We need to check L upon A. Now what is L? L is obviously length, and what is area? Area is pi r square. Okay, so L upon r square. So the change in length is proportional to length divided by r square. So we need to check for maximum extension. For maximum extension, we need a very high length and very low radius. Okay, so out of these options, which one have a smallest radius? Now, if you see that combinations are different for each cases. Combinations are different for each cases. So what we will be doing? We have to manually calculate for each cases what will be the ratio. This ratio is the only thing. Other things are constant, so don't worry that F is not given, Y is not given, not required. If you calculate this ratio, whoever is going to give you the highest ratio, that is your answer. Okay, so let's check the first one. Okay, L upon r square. So L upon r square we are checking. So 100 divided by 0.2 into 0.2. Again, Unit is not important here because eventually all of the quantities will have same unit, so does not matter. So 100 by 4 into 100. Okay, this point decimals I have converted here. So 25, so this is 2500. For this it is 2500. Now let's calculate the second one. It is 200 divided by 4 into 4 into 100. So what I am doing, I am converting this into 0.4. 0.4 is 4 into 10 to the power of minus 1. So 0.4 into 0.4 is 4 into 4 into 10 to the power of minus 2. So when you are writing this in division, basically you are converting it's multiplied by 100. Okay, so now let's cancel. It will be 25. Okay, just give me slight space. It will be 25 and this will be 50. So 25 into 50 is 1125. So this will be 1250. Okay, so obviously it is reducing. Now let's go for the second one. Third one will be 300 divided by 6 into 6 into 100. Okay, so 50 and it will be 325. So it will be 2500 divided by 3, that is approximately 800. Obviously less, so we do not care. This one, let's say 400 divided by 8 into 8 into 100. Okay, now you have, I guess you have understood the pattern. 50, this is 4, 25, 25, this is 625. So obviously as you can see, this one has the highest value. Okay, this one will give you the maximum elongation. So answer is option 1. Even though the length is not maximum, because the radius or it depends on the square of the radius. Whoever has the smallest radius will have a larger impact. Okay, remember, if the similar question comes, you just check which one have the smallest radius. That should be the option. If a combination is given, combination of length and radius is given, then you have to check which one have the highest length, smallest radius. Okay, but here length is given, length is increasing, radius is also increasing. So smaller the radius, higher is the elongation. So option A is correct. Next question. Where do we get first PYQs for KCET preparation? Sahana, that's what we are doing here. We are solving some important questions of P1 along with PYQ. So you can download this PDF. You can watch this lecture, answer along with all the students who are answering, right? You will get all here. Melo Universe, which one? Melo? Sir, how many chapters we need to concentrate on first PUC syllabus? If you really want to concentrate, as I mentioned, you have to at least first few chapters, that is units and measurement. Okay, not because the question will come only one of some of the chapters, but those are fundamental chapters. Fundamental chapter means based on those concepts, it will be helpful for you to answer questions in PU1 as well. Okay, so PU2 as well. So now because in PU2 chapters the questions will not be purely from PU2, as you know, right? This is not your PU exam. Here concepts from PU1 and PU2 can be punched together and give you and be given as a question as well in some of the concepts. So I recommend at least, okay, at least units and measurement, motion in a straight line, motion in a plane, laws of motion, system of particles, gravitation. These 6 chapters are must. These 6 chapters are must. Okay, the ratio of hydraulic stress to corresponding strain is known as. Now question from such as this are easy questions. So if you see a easy question and you have not studied, then you will not be able to answer. Sometime question can be difficult, sometime question will be easy. So if you see a easy question, you should be able to answer those easy questions at least. Okay, the ratio of hydraulic stress to corresponding strain is, that is called bulk modulus, okay, or volume strain, okay, volume rigidity modulus, okay. So it will be bulk modulus. Hydraulic stress to hydraulic strain is bulk modulus, okay. Now next question. So those who have answered option A, I don't know how many of you have answered. Some of you have answered B, I don't know why, okay. Pro Hacker and Prajwal, if you want to discuss, go and discuss outside. Sir, NCERT exemplar useful for KCET preparation. I told you multiple times, NCERT exemplar is a good book, but not updated according to the latest syllabus, so that will not be very useful. Okay, NCERT exemplar is still publishing their old syllabus books. The syllabus is not updated according to the latest syllabus. Even if you download the PDF, even if you buy the latest book from the bookstore, they are not super useful. You can use that as a practice material, but questions generally do not come from exemplar directly. A spring is stretched by applying a load to its free end. The strain produced in the string is volumetric, shear, longitudinal and shear or longitudinal. So we have a spring. We have a spring. How does the spring looks like? Spring looks like this. Okay, spring looks like this. So now if you apply some force on this spring, what will happen? It will extend. It will extend obviously longitudinally. So longitudinally means lengthwise. Longitudinal means lengthwise. So its length will definitely increase. So longitudinal strain is definitely there. Okay, if you change its length, longitudinal strain is also there. But one important thing about a spring is that it also have a shape. It also have a shape. Because of this shape, okay, when you apply a force, not only force will act along the length, force will also act along these joints, branches where it is curved. Okay, so there will be a shearing strength. Shear means what? Shear means suppose you have a object. Okay, you apply a force, a tangential force. You apply a tangential force, and because of the tangential force, the object now bend like this. Okay, so because of this tangential force, the object bend like this. This is called shearing force, shearing strain. Okay, this is called shearing strain. Anything happens lengthwise is longitudinal, anything happens volume wise is hydraulic. Okay, but anything happens tangentially, it is called shearing strain. Okay, so because the shape of the string is such that there will be tangential force acting on every curve, so that's why there will be a shearing strain as well. So longitudinal and shear is the correct answer. So correct answer for this question is option C. Okay, who answered volumetric? Who answered volumetric? Okay, I don't know who answered volumetric. So what is the relationship with volume here? Do you think that the volume of the spring will increase or decrease? Think. Young's modulus is defined as the ratio of bulk stress to longitudinal strain, hydraulic stress to hydraulic strain, shearing stress to shearing strain, tensile stress to longitudinal strain. Now here there is a small language change here. So longitudinal means along the length. Tensile means again linear, okay, along the length. So Young's modulus is given by stress by strain. Now stress can be multiple different things. Okay, for example, before your PU exam you were stressed about your PU exam preparation. Now after your PU exam preparation, now you are worried about your KCET preparation. Once both of them will be over, then you will be worried about your exam results. Some of you will be worried about Comet K exams. Okay, so stress is different at different stages, right? Similarly, strain is also different. Now your parents are maybe saying that you go study. After your result they will say what you have done. So strain will be different as well. So stress and strain changes depending upon the nature of the force. Okay, so here for Young's modulus, the force is acting linearly and the object is changing its length, or whatever it is changing, it is also changing in the linear direction only. So Young's modulus is defined by tensile stress, which is linear stress, and longitudinal strain, which is also linear strain. So correct answer is option D. Okay. Noor, not option A. Bulk stress, longitudinal strain has no meaning. Bulk stress by bulk strain is bulk modulus, which is hydraulic stress by hydraulic strain. Hydraulic stress by hydraulic strain is same, bulk modulus. Shearing stress by shearing strain is shearing modulus. Okay. Now let's move on to the question number 22. A stretched wire of material, okay, stretched wire of material whose Young's modulus y equals to 2 into 10 to the power of 11 Newton meter square has Poisson ratio 0.25. Its lateral strain epsilon I is 10 to the power of -3. The elastic energy density of the wire is. So this is again easy question if you know what you are doing. If you don't know, that will be a little complicated. So energy density is given by, what is energy density? The formula is Young's modulus into longitudinal strain square. Longitudinal strain square. Okay. Now if you see in the question, longitudinal strain is not given. Okay, here lateral strain is given. Now what is Poisson ratio? First of all, let us understand that. Okay, as I mentioned during the lectures, we will explain the theory portions as well. So here we have a wire. Because we are talking about Young's modulus, that means the force that we are applying on it must be linear force. Okay, to change its length. Okay, the force that we have applied on this system, it is basically change its length. And when the length changes, where do you think the material, extra material is coming from? Where do you think the extra material is coming from? Length is increasing. So can you increase the material inside? You are not able to change the material inside. So what happens is that the object which was initially this big, okay, this is not a drawing mistake. Okay, I intentionally draw this one little thinner. Okay, so what happens is that the object which was much larger in diameter, its diameter shrinks or diameter gets reduced. Okay, so same material, when you stretch it, it becomes thinner. Okay, and Poisson ratio is basically talking about the change in its diameter. Suppose the initial diameter is capital D. Okay, the change in diameter is delta D. Okay, Poisson ratio talks about Poisson ratio is given by this symbol, is given by delta D by D. Let me write it capital D. Delta D by D, that is change in its diameter. Change in its diameter divided by change in its length. Change in its length we have used, right? Change in its length we have used in case of Young's modulus. So this is a new quantity and there is a negative sign here. Poisson ratio is denoted by a negative sign. Why negative sign? Because if length increases, diameter decreases. If you compress it, if length increases, length decreases, diameter increases. Okay, so they are one increasing, another one is decreasing. That's why there is a negative sign. This is Poisson ratio. Now in terms of strain, it is mentioned this one is called lateral strain. This one is called a lateral strain, I, epsilon I. This one is called longitudinal strain. Okay, longitudinal strain we have studied already. Okay, this one is called lateral strain, this one is called longitudinal strain. This value for this question is given as 0.25. Now for normal problems we will ignore the negative sign. Okay, epsilon I actually has to be negative anyway, So epsilon I is given here 10 to the power of minus 3. So epsilon L from Poisson ratio calculation, it will be lateral strain divided by Poisson ratio, that is 10 to the power of minus 3 divided by 0.25, that is 4 into 10 to the power of minus 3. Okay, so lateral strain is calculated. Now we will go back to our energy density formula. Okay, this one also you have done the derivation if you remember. Okay, but anyway most of you don't remember Q1, so you have to memorize the formulas. So Young's modulus is 2 into 10 to the power of 11 and epsilon L is 4 into 10 to the power of minus 3 whole square. So it will be obviously 2 cancels, you get 10 to the power of 11 into 16 into 10 to the power of minus 6. So it will be 16 into 10 to the power of 5. Okay, 16 into 10 to the power of 5 joules per meter. So option A is correct. Okay. Sir, increase volume. I think you check your device volume, Prajwal. Volume is maximum. What is, sir, explain it but simplify it. Okay, so simplification is, okay, I have explained it in detail. Let me, if you want a simplified answer, let me do that as well. Simplification is that, remember Poisson ratio is given by lateral strain by longitudinal strain. Okay, so longitudinal strain is Poisson, not Poisson, so cross multiply, it will be lateral strain by Poisson ratio. Now these values are given in the question. Okay, this one is given 10 to the power of minus 3, this one is given 0.25, that is 4 into 10 to the power of minus 3. Okay, now what about Young's energy density? Energy density is given by half y into delta L by L whole square. Now what is delta L by L? Delta L by L is called the lateral strain. So lateral strain means it is simply epsilon L whole square. Okay, so now put the values over here, half into 2 into 10 to the power of 11 and epsilon L we have calculated from the problem, which is 4 into 10 to the power of minus 3. So square of that, if you cancel everything, you will get 16 into 10 to the power of 5. Okay, 16 into 10 to the power of 5. So correct answer is this one. Okay. A thick metal wire of density rho and length L is hung from a rigid support. The increase in its length of the wire due to its own weight. So basically when you hang some, say, a object, okay, so it is basically expanding due to its own weight. Suppose the change in length is delta L, original length is L. Original length is L and change in its length is delta L. You applied external weight, which is mg. Okay, now it is expanding due to its own weight. This is very interesting question. Now here if you see in the expression, a lot of things are given. Neither mass is given but g is given. So what we have to do, the problem in this question is basically converting this mass into something else. What is that? Mass, we know this is density, rho is density, right? Rho is given by density of the material. So mass is given by volume into density. Okay, density is mass per unit volume, so mass is volume into density. Now what is volume? Volume, if you know the cross sectional area, then if you know the cross sectional area, okay, and density of the material and length of the wire, then the volume is given by length into area. Okay, length into area. It is applicable to any shape and size. Okay, for example, this is also area into length. Okay, pi r square L. Pi r square is what? Pi r square is the area. Length is length. Okay, so pi r square L is the area into length. So remember that volume of an object is length into area. So mass is LA rho. So what is the weight? Weight is mg, which is LA rho into g. Okay, this is the weight. So this is the force. Here you can say this is the force that is acting. Force acting here is mg, which is LA rho g. That's it. If you understand up to this point, everything else will be followed through. Next part is Young's modulus. Young's modulus is given by force divided by area divided by delta L divided by L. Okay, so this is the Young's modulus. So if you simplify that, you will get F into L divided by delta L into A. Now we are trying to find the change in its length. So change in its length is given by F into L divided by Y into A. Okay, it will be F into L divided by Y into A. Now put this force in this and simplify, that's it. So LA rho G into L divided by Y into A cancels, and you get rho G L square upon Y. Okay, rho G L square upon Y. This problem is simple if you understand that what is weight and how can you convert the mass in terms of length, area and density. That's it. Okay, otherwise very simple, easy, just simple Young's modulus formula is sufficient to solve this question. Two wires A and B are made of same material. Their diameters are in the ratio 1:2 and lengths are in the ratio 1:3. If they are stretched by the same force, then increase in their lengths will be. Same material means Young's modulus is same. So that means F divided by area divided by delta L into L. So again we will simplify F into L divided by delta L into A. So we are trying to find delta L. Delta L is FL by Y into A. Obviously F and Y are constant. So for and also F into L, what is area? Area is pi r square. Okay, because in this question the ratio of the diameters are given. Okay, so just change that. So what is area in terms of diameter? Area is pi r square, that is pi into diameter by 2 whole square, that is pi upon 4 d square. Okay, put that over here. So you will get pi d square by 4. Okay, so now if you see that F is constant, this 4 will be constant, pi square is constant, Y is constant, not pi square, pi is constant, Y is constant. Only thing that is changing is length and diameter. So the change in its length is proportional to length upon diameter square. One problem we have solved similarly, their radius was there. In this problem diameter is there. Okay, so two wires A and B. So we can write delta L of A divided by delta L of B must be ratio of LA by DA square divided by LB by DB square. Okay, or LA by LB into DB square by DA square. Okay, now if you read the question, the length of the ratio is given 1:3, so ratio will be 1:3, and the ratio of the diameter is 1:2. So DA by DB is 1/2. So DB by DA is 2. So here it will be 1/3 into 2 square, that is 4/3. So correct answer is 4:3. Correct answer is 4:3. Prajwal, for that you have to join KC30. Okay, KC30 we are conducting Zoom classes, students are interacting, right? FRP is right. What is FRP? Speaker was gone. Speaker is coming perfectly. Okay. Oh, your phone speaker is gone. Okay. Then use headphone. Use headphone. How are master stroke if anyone is watching? The Deepti. Deepti, I can tell you that master strokes are obviously one of the best lectures that we have done personally. Okay, whether you like it or not, that is up to you, but master strokes where we have put a lot of effort while preparing the PDF, preparing the lectures and delivering the lectures. Master stroke for your PU1 will also come very soon. Don't worry, it will start coming very soon. So PU1 lectures chapter wise will also be coming very soon. Okay, and if you combine that master stroke series with this live series, your preparation will be very good. Okay, now let's see. An ideal fluid flows through a pipe of circular cross section with diameters 5 cm and 10 cm as shown. The ratio of velocities of fluid at A and B. So obviously here we have an area A, here we have an area B. Okay, now there is an equation called equation of continuity. Equation of continuity says that velocity into area is constant throughout for ideal fluids. Okay, for incompressible ideal fluid, that is streamline motion, VAA, A is the area of A, B is area of B. Okay, so if you multiply VA into A, you will get equals to VB into B. Okay, now what is area? Area is pi d square by 4. Don't ask me why, because I have just done it in the last problem. Okay, equals to VB into pi dB square by 4. Obviously these constants are cancelled, so you get VA dA square equals to VB dB square. Okay, so diameter of one is 5, so VA upon VB equals to 10 square by 5 square. Okay, dB is 10, dA is 5, so it will be 100 by 25, so it will be 4. So correct answer is 4:1. Okay, VA by VB will be 4:1. Make sure in any ratio based question, make sure double check your answer, because there will be an option where 4:1 and 1:4 will be given. So if you make a slight mistake in that, one side you have done it correctly, other side you take a wrong step, and your ratio will be completely opposite of what you are looking for. Okay, so make sure ratio based question, very big warning to all of you, those who are watching right now, make sure that you why can't be. That's what I'm saying, Prajwal. It is A and B. The order has to be A first, B next. Okay, the ratio has to be in the order of A and B. Okay, so all ratio based question, you make sure that you double check your answer. You double check your answer that the order that is given here, are you doing in the proper order or not. So if you still have doubt, I am just explaining once more. So if you see after this, VA by VB is given by DB square by DA square. Okay, so from here you can see that VA by VB is DB square by DA square, cross multiplication. So make sure you have done the cross multiplication properly and your order is correct. Okay, then only you will be able to answer. Now next question, question number 26. Hydraulic lift works on the basis of which one? Okay, please answer it in the chat quickly. Let me have some water. What is hydraulic lift? Hydraulic lift is, suppose we have, this is called hydraulic lift. It is very useful if you have seen some car washing or bike repairing mechanics. They use some machine and it goes up, okay, and they wash the bottom of the car using water. So that those things actually work under the principle of hydraulic lifting. Okay, in fact the braking system of your car also uses hydraulic lift. Okay, what is the system? So you actually have this. If you apply a very small pressure over here, this thing lift up by a high amount. Okay, so small pressure here actually can lift this by a very large amount. Or if you apply a small force over here, okay, it can lift a very huge object. Okay, by this is also possible. If you apply a small force, it can lift a huge object. Here if you apply a small force, it will lift by a huge margin. The length increase will be very high. Okay, so this is called hydraulic lift, and hydraulic lift is based on, obviously, Pascal's law. Pascal is the person who says that any pressure you apply, it will always travel in all direction of the fluid, and it will basically, whatever pressure you apply over here, that will transmit to this portion. So this is the Pascal's law, not Stokes' law, not Bernoulli's principle, not Torricelli's law, but Pascal's law. Question number 27. The pressure at the bottom of a liquid tank is not proportional to acceleration due to gravity, density of the liquid, height of the liquid, area of the liquid surface. What is your problem, Vimal Deshpande? If you want to have something, you can discuss in another chat, not here. Yes, Sheikh, what is, why should I excuse you? You have any question? Sir, how many questions are still there? 3 more questions, 30 questions, up to 30 questions. Question number 26 once more. Hydraulic lift. Hydraulic lift works under the principle of Pascal's law. Pascal's law states that if you apply a pressure into a liquid, okay, that pressure is basically transmitted to all parts of the liquid equally. Okay, so if you apply a small pressure into a liquid, that pressure will be equally transferred into all portions of the liquid. So that means if you apply a pressure over here, the same pressure will be applied on this region as well, same pressure, and pressure remains constant, but pressure is also, force that you apply is actually pressure is actually force divided by area. By changing the area, you can adjust the force and you can lift objects. That is the principle of hydraulic lift, which is Pascal's law. Okay. So what time the class will end daily? So it depends, Sheikh. For example, today's class I started a little late. There was some issue happened at our end, so classes started at 6. So generally it generally ends within 2 hours. Okay, 2 hours is general time. In morning classes generally it takes sometimes 3 hours, but evening classes we always try to keep it by 2 hours. So generally you can max to max, you can imagine 5 to 8 will be the range. Okay, for example, tomorrow I think Ankit sir will be taking the live little earlier, okay, because some of you have your favorite RCB match coming up. So Ankit sir was saying that he will be taking class a little earlier. Sunday also I will be taking class little earlier. Okay, those who want to watch some matches after that, they can watch. Okay, Sunday class anyway I also have to go home, so I will be taking the class 4 p.m. in the afternoon. and it will go around 6:30. By that time it will be over. Okay, today's class I started little late, that's why it is going little late. The pressure at the bottom of a liquid tank is proportional to the pressure at the bottom of a liquid tank. If you try to calculate, it actually consists of two portions. One is called gauge pressure. Gauge pressure is nothing new, you already know, which is rho GH. This one is called gauge pressure. Okay, now in class 11th or PU1 you have also know that total pressure is not only this gauge pressure, but you also have to add the atmospheric pressure. Okay, now if you see that here they have not mentioned whether it is gauge pressure or total pressure. Anyway, the pressure, if you calculate the total pressure or gauge pressure, does not matter. It depends on density, depends on gravitational constant, depends on depth. Okay, here H is the depth. Okay, not height, it is the depth. So it depends on acceleration due to gravity, depends on density, depends on height, but anywhere in this formula there is no relationship with the liquid pressure or area of the surface, so it is independent of the area of the surface. Okay, because it mentioned not proportional to, not proportional to. Make sure you read the question, then you answer. Okay, now next question. A cylindrical container containing water has small hole at a height of capital H equals to 8 centimeter from the bottom and at a depth 2 centimeter from the top of the surface. The maximum horizontal distance traveled by water before it hits the ground. Now this is a tricky question. This is not easy. So what is here happening? Here we have an open container. Okay, we have an open container and there is a small hole here. So liquid will come out of this, and how the liquid will come out? Liquid will come out like this. Okay, liquid will come out like this. So they ask you what will be this distance? What will be this distance from the ground? Now how to do that? So first of all you have to memorize one formula which is called Torricelli's law, that the speed of the liquid which is coming out, the speed of the liquid which is coming out is given by square root of 2gh when this portion is open. Okay, this is open, then only this formula is valid. If this is closed, we will see in another problem how to answer that as well. So if this is open, remember that the speed of liquid which is coming out is given by square root of 2gh. Now this speed is in horizontal direction. This speed is in horizontal direction. What force acting on this water so that the water is falling down? The only force that is acting on the water is force of gravity. Only force which is acting on this water is force of gravity. That means this water is actually accelerating downward with an acceleration due to gravity which is given by g. Okay, now this motion and this motion are independent. Any two perpendicular motions are always independent. Okay, this is the gravitational acceleration, this is the horizontal speed. Okay, now these two motions are independent, and these two are independent means what? You can calculate them individually. This speed remains constant, this is accelerating, so speed is changing, and this is the cause that this water is falling down. Now the time that it requires to bring down the water from here to here is same here to here, because those are independent motions. So first thing we will try to calculate is how much time is required to bring a drop of water from this height from here to here. Okay, so this is depth based formula. For this one we need to use the height. Okay, how to calculate that? We know that distance traveled is given by half gt square, because initial velocity is 0. ut plus half at square. U is 0, so the distance traveled is half gt square. So from here we can calculate time. Time will be 2h by g. Again time is square root of 2h by g. Okay, now what is this distance? D. This distance d will be velocity into time. Okay, Now because there is no acceleration in this direction, only constant velocity, so velocity into time is the distance traveled. So what is the velocity? Velocity is square root of 2gh, and it will be square root of 2h by g. Okay, g cancels and you get square root of 4hh, okay, or square root of 4 into 2 into 8. So it will be 2 into 4, that is 8 centimeter. So the distance here is 8 centimeter. Correct answer is option B. Wow, Vimesh answered correctly. Correct. All of you are correct. Now, next question. A closed water tank has cross-sectional area A. It has a small hole at a depth h from the free surface of the water. The radius of the hole is r, so that r is very smaller than a by root pi. P naught is the pressure inside the tank above the water level. Here is the pressure above the water level. Pa is the atmospheric pressure. The flow of water coming out of the hole is rho is the density of the water. So this is again Torricelli's law, but here it is a closed container. Closed container means atmospheric pressure is not acting from this side. Okay, normally what happens in a closed container, atmospheric pressure is acting from this side, atmospheric pressure is acting from this side, so these two gets cancelled. Okay, here atmospheric pressure is not acting from this side, but there is a different pressure PO. So you need to take the difference in pressure. You need to take the difference in pressure PO minus PA. Okay, so you have to take the difference in pressure. So that means normally what is the formula? Normally formula is 2gh. So here it will be having some terms related to difference in pressure. So if the side is open, then these two are equal, so this value becomes 0. But if they are not open, they are not 0. Okay, so now what is the flow? Flow rate, this is velocity, this is not flow rate, this is velocity. There will be other term as well. Okay, I think rho into only rho. Okay, so this is the normal velocity. But what is flow rate? Flow rate is velocity into area. Continuity, equation of continuity, this is constant. Okay, velocity into area. So what is area? Area here is V into pi r square. Okay, this is how you calculate the flow rate. Okay, flow rate is pi r square 2gh plus 2 into P naught minus Pa by rho. Now if you forget this equation, how to remember? So you have to, first of all, you have to remember this is a closed pipe. So obviously this is not correct. This is not correct any cases, be it open or closed, because this represents the height of water. Height of water, it does not depend on height of water. All hydrodynamics related problems, they depend on depth only. Okay, pressure, speed of efflux, this is called speed of efflux. They all depends on depth only, not on height. Okay, so it does not depend on height anyway. Now if you see these two equations, you see that this one does not have this 2gh. Okay, so this 2gh is essential. If you make PO is equal to PA, okay, then this should be 0, so there will be square root of 2gh. So here 2gh is there, here 2gh is not there, so definitely this is incorrect, this one is correct. This is how you eliminate. Okay, if you know half of the answer, that is 2gh has to be there. Okay, half of the answer you know, remaining this thing you forgot, then obviously you can see that here gh is simple gh, here 2gh, so this will be the answer. Okay, now let's move on. Water flows through a horizontal pipe of varying cross section at a rate of 0.314 meter square per second. The velocity of water at a point where the radius of the pipe is 10 centimeter. So flow rate is given. Okay, let me write it like this: 314 into 10 to the power of minus 3. That will be helpful. Okay, so flow rate is given. The radius of the pipe is given. Radius of the pipe is 10 centimeter. That is 10 into 10 to the power of minus 2 meter. That is 10 to the power of minus 1 meter. Okay. Now they ask you what is the velocity. What is flow rate? I just told you flow rate is velocity into area. Okay, flow rate is velocity into area. Now flow rate is given, velocity we are trying to find, area is pi r square. So velocity is 314 into 10 to the power of minus 3 divided by pi r square. Okay, so 314 into 10 to the power of minus 3 divided by 3.14, because pi is 3.14, r is 10 to the power of minus 1 whole square. So you cancel this, you get 100 over here. Okay, 314 by 3.14 is 100. So you get 100 into 10 to the power of minus 3 divided by 10 to the power of minus 2. Okay, square root of this. So 10 to the power of minus 2 minus 3 cancels, you get minus 1 over here. So your answer is 10 meter per second. So correct answer is 10 meter per second. Option C is correct. Hello Tanjiro. Hey, what are you doing here, Tanjiro? Your friend Ganeshu is looking for you. Right? Now, sir, how many extra questions we have to solve apart from PYQ? You as many as you can. Okay, not chapter wise, but at least a bulk volume wise. If you practice more questions, you will be better. But remember that whenever you are practicing questions, maybe it is PYQ, maybe it is extra question, always practice with timer. Always practice with timer. Practicing without timer is like running without any aim. Okay, if you practice with timer only, then you will be realize that how much time I require to answer certain question. That is essential. Okay, answer with a timer. That is very, very important for you to answer. Who is waiting? For Tanjiro, his friend Genisu is waiting. Okay, Tanjiro is asking what is the important chapter? Improvement chapter or important chapter? I already mentioned important chapters. Now those who have missed it, P1. Now why I am saying important, not only because the questions coming from this chapter, but the concepts are being used in other chapters as well. That's based on that I am saying P1 chapters. If you study all 14 chapters, each chapter will have 1 questions each, and some chapters will have 2 questions each. Okay, total 19 to 20 questions will come in the exam. Now I will tell you these chapters you should study. Units and measurement. Study means study the theory, at least revise the chapter by reading the summary of the chapter, or once the lectures of master strokes are out, you can check them as well. Okay, theory portions you need to study briefly, at least. Units and measurement, motion in a plane, motion in a straight line, motion in a plane. Okay, 1D is straight line, 2D is plane. Next is laws of motion. Okay, next is work, energy, power. Next is system of particle, and last is gravitation. Okay, out of these, this one, this, and this, all these chapters you will get 2 questions. Okay, all these chapters you are going to get 2 questions. Motion in 1D, 1 question. Units and measurement, 1 question. But these concepts, these chapters in my opinion are fundamental chapters. Fundamental chapters means units and measurements, concepts, dimensional analysis, unit analysis. These concepts can be asked from PU2 chapters as well. Motion in 1D, where you learn about equations of motion, how to solve a problem, that can be used in your PU2 chapters as well. Motion in 2D, anyway it is important. From this chapter you learn vectors, addition of vector, multiplication of vector, that again can be used in your PUC, second PUC chapter. Laws of motion, again concepts are important, 2 questions comes. Again from this chapter the concepts of Newton's third law, again all can be used in the second PUC chapters. Work, energy, power, the relationship of kinetic energy. If you have watched my last lecture, there I have given you relationship between momentum and kinetic energy. They are all again important and can be used in the second PUC chapters. System of particle, as it is important chapter. Torque, okay, torque, moment of inertia, these are important. Now if you have not studied system of particles at all in future, in past, okay, then you can skip this chapter. Okay, star means not important, star means you can skip this chapter if you have no idea about this chapter. Okay, if you had at least a run in the Q1 when the teacher taught in the class, you have prepared some concept, because this chapter as it is, it's not super easy, it's difficult. Okay, because linear motion, our brain, when we come to system of particles, our brain is stuck into linear motion. Rotational motion, we cannot roll the car, right? So the wheels does not roll. So that's why system of particles can be tricky if you have not understood. But if you have at least had some understanding, you can revise this chapter, not in depth but KCET level at least. Gravitation, again gravitation is important because 2 questions comes from this chapter. Easy chapter, simple chapter. Remaining chapters, at least read NCERT summary. Read NCERT summary. Okay, these chapters are important, and read NCERT summary for the remaining chapters so that those chapters can be prepared quickly. Okay. Okay. If you have not studied system of particles, this is an optional chapter. You can skip this chapter, but 2 questions comes from this chapter. Just at least read the summary and also try to solve the PYQs which you think you can solve. If you think that okay, I will, even this question comes in exam, I will personally not be able to solve it, skip those PYQs for P1 chapters. Okay, if you think that if I will be able to solve this question, solve it. If you think that okay, I will not be able to solve this question in the exam, there is no time to waste. Okay, that is the main thing. PYQs you have to practice. Okay, at least for system of particles there may be an easy question that came, like for example 2024 exam, 1 question was easy. Okay, 2025 both questions was difficult. Okay, 2024 1 question was easy, you could have answered that even if you had a basic idea of rotational motion. Okay, so try to answer those easy questions at least. You should not miss out on any easy question from PU1, right? Sir, please, if solve PYQs or P1 is if enough with your concept videos, yes. PYQs will give you an idea what type of questions is coming. Okay, PYQ is must. It is not only enough, it is must. Along with that, if you practice more questions, that is great. Okay, that will give you an idea if unknown question comes, how to tackle those. Even though you have solved, you know the concept, you have solved similar questions, but exam hall, no, the brain does not work properly. It actually, you are little afraid, you are little tensed, so your brain functions little slower than in exam hall. So once you start answering those questions, your confidence builds up, and that anxiety in the exam hall slowly goes away. But if you are already practicing that beforehand or at your home, at your peace, then that anxiety goes away much faster than if you are only practicing PYQs, if you are only practicing watching lectures, practicing PYQs, then that might take a little bit longer in the exam hall. Okay, so more practice you do. I am not asking you to purchase ABHYAS. If you have ABHYAS, very good. If you don't have ABHYAS, whatever textbook you have, MTG or whatever it is, okay, in fact the price of ABHYAS is much cheaper than entire set of MTG, so that is up to you. Anyway, if you have ABHYAS, you can practice. If you do not have ABHYAS, try to get it. Only 999 is the price. If you have MTG, you can practice from MTG, no problem. If you do not have MTG, at least have one practice material for questions. Okay, that is very, very important. Okay, so that's it. I will like to, the class is extended a little bit more than I intended. So this is it. I will be meeting you on Sunday at 4 p.m. Be there. Okay, see you in my next